Alright, welcome to the lunchtime video for the JNCIE-SP. Time's moving really fast. They don't recommend signing up for the exam until you're within 30 days of taking it, so it's not quite that time yet, but in just a few weeks I will be registering for it. So a little bit concerning because you can see I've only gotten through I haven't even gotten through halfway of the material, so it does look pretty dire. The good news is if I can finish this LFA, that will be the end of high availability techniques, and I can move on to VPNs. And at that point I will be, let's see here, 1, 2, 3, yeah, I'll be more than halfway through, but you know, it took me like the better part of a year to get halfway through, so kind of bad news all around, but we'll see what happens. The good news is I did actually already go through VPNs as part of 960, the original version of the exam, and not only that, QoS I have real world experience with, so I'm pretty comfortable with that to some extent. Multicast, however, that's going to be a big one that I didn't get to. Okay, so let's make the new title for this next video. And in the last video we learned that LFA stands for a loop-free alternate. And we found an example where you would create a loop-free alternate using your IGP, in this case ISIS. I'm not sure if OSPF also has this capability, but this is something that is a part of ISIS in the example we're using. Yeah, I think loop-free alternates are meant to be, are just for ISIS. So the last video, what we did is configured all of the routers. Didn't get to the last two, so that's how I'm gonna start this video. Okay, so it's gonna be router 5 and router 6. Okay. Oop, I might need to take a quick break. I'll be right back. Alright, I'm back and I'm recording, so we're gonna configure router 5. Oops. Oh, I don't want to do a show descriptions. Perfect. Okay, so R5 to R4. So we're going to start with GE001. Now this one often has times auto-completing, and you can see the reason for that is because there are two options. There's interface and there's interface group. So when I auto-complete it, I don't get an extra space at the end. I have to hit the space bar twice because it doesn't know if I want that interface dash group option. But for something else where it doesn't have multiple, like for example, max areas, if I hit the, if I type A and then I hit a space bar, you can see I've got an extra space at the end. That's because there's no other options that start with an A. There's options that start with H, L, and S, but this is the only one that starts with an A. That's different than interface. We've got another option that starts with these letters. So that's why I don't have an extra space at the end. So you can see they've got an error here. There's no LDP option without the protocols first. So easy one, not worth a download in my opinion. Okay, one more router left. This is going to be R6R5, so we're going to start with GE001. Oh, so you can see there's something interesting going on here as well. The lines here got flipped. So I'm just going to do them in the order they were meant to be and include that family MPLS knob. Oh, so here's that. Yep, this has interface and interface group, so I need to push the space bar twice when I autocomplete this command. Really kind of affecting my rhythm because it's rare when that is necessary. I'm kind of interested in what that interface group does. Interface grouping configuration. I don't remember if I've used that or not. It seems to be different from admin groups. I know I have used that before. Oops, and I think I skipped the line preceding this. I'm just gonna finish everything first and then go back and put in the one I skipped. Oops. Okay, yep. So it was in a different order. SPF options is now at the top instead of the bottom. That's why I had trouble seeing that. Okay, so it's time for the verification steps. First step is going to be verifying the routes. So on device R1 from operational mode, run the show route command to display the routes in the routing table. Okay, and we should see a loop-free alternate route eventually. Oops, so it's going to be show route 1.1.4/24. Oops, so it looks like I don't have. Okay, so I wondered if so the reason I just copied what they had there because I wondered if you could abbreviate it like that, like if it was a .0 you didn't have to include it, but okay, it looks like that is a valid abbreviation. It's just I don't have that route yet. Okay, so that's interesting that I don't have that route. Let's see which device this route will be sourcing from. Okay, so it's meant to be on router 5. Let's take a look. Oops, so it looks like, oh, yep, so it looks like I do have it. That's good news. Let's see if I can, if it's in the routing table. So show route protocol direct. Yep, it's in there as a direct route. So here it is. Now what's interesting is that it's not being learned through ISIS, so let's make sure that port is included in ISIS. Looks like it is. Let's see if we've got ISIS neighbors. Or it's going to be adjacency. Okay, and we've got all of our adjacencies up. Okay. All right, so I guess I don't understand why it's not being learned on router 1. Um, Okay, well let's check another router and see if it's being learned there. So it's sourcing from here. So let's check this other side here and see if it's learned. Okay, so yeah, it's learned here, and it's learned via GE1, so via here. So I'm thinking there's some sort of broken link where the IP addressing is not the same on both sides. Oops, I'm gonna have to take a quick break. I'll be right back. All right, I'm back and we are recording. Yeah, this is turning out to be kind of a fun troubleshooting exercise. We saw that, so we can see that on router 3, this one here, it is learning it through this way. So it seems like the ISIS traffic is fine going this way. On this one here, it didn't learn the route, so it can learn it going either way. But ISIS is a SPF algorithm, and these are all the same links. So if these links were faster than these links, yes, it could learn it this way, but since they're all the same speed, they have the same cost, it's gonna want to learn it this way instead. So I think what's going on is this link here is having an issue, and I know that because the route showed up here as a directly connected route. So I don't think there's any issues with this link. I guess I don't know that for sure with Cisco. The route won't show up unless there are problems with the link, but that's actually one of the differences between Cisco and Juniper. So I think both of these links are going to be good to check for troubleshooting. And this is something I've got to be really concerned about during the test because I have very limited time, so I can't waste time spending on red herrings, on stuff that is not related to the issue. So I'm going to start off by troubleshooting this link, making sure it can ping across, making sure the IP addressing is right, and then if I don't see anything, I'll move over to this link. Okay, so this is going to be GE000 for both R1 and R6. Oops. Okay. Oops, so we can see we do have a discrepancy here. We see we've got the wrong description. It's going to be 001 that goes to R2. So that could be the problem right there. Let's check R6. Yep, so I found the problem. The problem is that I accidentally configured the port 000 with the configuration meant for port 001. I likely did the vice versa of that as well. Let's verify that. Yep, so I did that as well. You can see that the port with the description R1 to R6 has an address in the same subnet as the port on R6 with the description R6 to R1. So clearly this port is meant to be the port connected to R6, but my mistake is that I configured this on the port connected to R2. Okay, but that's actually pretty easy to fix if you're familiar with the command, with the knob display set relative. It makes it really easy to fix errors like this. So the first thing we're going to do is go into both of the interfaces. Okay, and then we're going to do a show pipe display set relative on each of them. Okay, so now that we've got this here ready to use, we can stay in 001 and delete everything under it. And now go to the configuration that was under 002 and apply that. Okay, so now we can move to 000, delete everything under that, and now apply everything that was meant for 001. So you can see show pipe display set relative is a really powerful knob to learn, because it can allow you to make really fast changes like this. Okay, so now we've got ETH02, which translates to GE000, with the description R1 to R6, which matches what's in the topology. And likewise, we have E3, which translates to GE001 with the description R1 to R2, which is what is shown in the topology. So let's commit that and take another look at the verification step. The first verification step here, verifying the routes. And we've got a ISIS route now. So one thing that we don't have though is that backup route. So there might be another mistake in the network where it's not able to learn it from that other side. Now, I'm a little bit surprised that they would have two of them like this, because I think it won't show up unless they're cost equal paths, but I guess I'm not sure about that. So I still am, I think, going to verify that it has the capability of learning it through GE001. So let's go to R2 and see if it has the route. Okay, so R2 has it through GE001. Yep, and everything looks good on the link there. So it does appear to have the ability to learn it through the other side. But since it's not a cost equal path, I wouldn't have expected it to do so. So I'm not sure why it's learning a cost equal path here. It looks like it's learning it by way of some mechanism of MPLS, because you can see it is pushing a label onto it. Now I do have this, okay, so I do have it exported ECMP, perfect. So everything I think is fine. Alright, well let's go through, take a look at the detail. I'll just keep doing the verification steps because maybe there'll be some clues. So here they've got, yeah, so they've got the same next hop as I do, but they've got another next hop here that is missing from my output and all the label information. So it almost seems like something happened with MPLS. Let's check the MPLS neighbors or the LDP neighbor. Okay, yeah, everything seems fine. I'm a little bit tempted to go and verify all of them with these commands, but of course I do want to save as much time as possible. Time is going to be precious and limited during the exam, so I don't want to get in the habit of wasting it. Okay, so here they have LSP with the next hop being an IPv4 address, but they also have it with the next hop of being a LSP. And if you look at my entry, so hopefully I can filter that down. There we go. I only have it through IPv4. Something is gone very wrong with my LDP, where I don't have the next hop being learned through an LSP formed using that LDP, because there appears to be an issue with that. So, so here's how we verify the LDP routes. This is going to be important for fixing this issue. So I have a feeling something is very wrong with this output. So we've got connection open, that matches theirs. We got state operational, that's the same. So it doesn't appear to be, at first glance, problematic. Yep, the IP addressing matches. It's auto-targeted. We've got a local address here and a remote address that matches the output they've got. And we can see very clearly it is up, and it has been up for 5 minutes, so this does not seem to be what the issue is. Okay, so let's take a look at the ISIS backup shortest path first results. Okay, so here's the command. Now we can, now I'm surprised that they are entering R6 after this. It looks like there's no, yeah, that's not a valid option. Perhaps I can do instance or topology or something. Topology, nope, so maybe it's instance. Does that work? No. Yeah, so I don't know why they have R6 there, but that's the one they want to look at. So let's just narrow it down by just looking at it. So Okay, so we do have entries for R6. All right, so we've got the output for R6. Let's see how that compares to what's in the verification step. So it looks like the output is, oh, you know what? Results R6. Did I leave off an option? No, I have that. So 6.0. Huh, okay, well, I'm not sure what's going on there. We do have results though, but we just don't have detailed results. Maybe I can add the knob detail and get more detailed results. Nope, and you can see of course it's not a option here, so of course that's not going to work. Yeah, so of course I'm using a different OS version than they are, so I don't have the same options. So let's just see if the SNPA matches. No, it looks like it's different. So the output indicates whether a specific interface or node has been designated as a remote backup path and why. So clearly something went wrong with that. A backup has not been, a specific interface has not been designated as a remote backup path. Oh, so this is interesting. It looks like I get the option to add a hostname now. Yeah, so it looks like I've got that. So I must have mistyped the command earlier. Let's see what the difference was. So it looks like earlier I did show ISIS SPF results, but now I did show ISIS backup SPF results. So I don't know why my eyes just glitched out on that, but it's good news that I have it. Ah, so we've got some things saying not eligible. So let's see the difference now. So it looks like we've also got different SNPA addresses. They have not eligible as well, but they do have one that says that it is eligible in stark contrast to what I have, which is every single one says that it's not eligible. So So the reason is interface protection was not configured. So clearly there's a difference between their R4 configuration and my R4 configuration. It looks like interface protection was not configured. So let's see if I can configure that. So this is R4. All right. Okay, so let's see what configuration they had. Now, I think it would go under here. It would just say link protection. I think that's what they're referring to. Let's just look at the answer key. I'm kind of running out of time. I'd like to just see if that's the case, but I do need to be moving quick. So it looks like everything is correct. Yeah, so we've got 1, 2, 3, 4, 5, 6 lines here, and we've got, oops, so it looks like we are missing a line. We've got the aggregate, auto sessions. Oh, okay, so this probably disappears. Okay, it looks like I'm missing another line. Nope, it jumps to the top. So yeah, I configured it all right. I've got the ISO NET address right. Got the loopback right. So I think they just kind of left me high and dry and forgot a command that is necessary for this all to work. So let's enable link protection. So yeah, so an eligible backup next hop we're going to have being a next hop to this address, which is the loopback address. So I think it would be set interface hello 0, 0, and then link protection. Will that work? Okay, let's see if that works. Okay, so it's still not eligible. Let's just do a pipe match to get the results more clear. So still don't have anything that is eligible, and it's because interface link protection is not configured. I thought they did say to configure interface link protection on one of the routers. Yeah, so they said to configure it on router 1. But that's the only router where they said to configure link protection. It looks pretty clear that link protection is meant to be enabled on more than just router 1. Well, let's see if link protection is even configured on router 1. I might have missed it. So yep, I do have link protection enabled. I have it on GE001. They have it on the interface with the description R1 to R6. Let's see if I have it on the right interface. So GE01 has the description R1 to R2. So it looks like I've got a link protection configured on the wrong interface. Let's, before I do anything else, revert the change I made on here. Okay, and now let's fix that mistake I've got with link protection on the wrong interface. Okay, so it's currently oh, okay. So it's not going to be configured under the actual interface. It's going to be configured under ISIS. Okay, so now we've got link protection enabled, but we can see that it's only enabled on GE1. If I do a show in descriptions, we can see that GE1 is the interface with the description R2 to R1, but they have it enabled on 150, which is the interface with the description R1 to R6. So I've got to disable this knob here and then toggle the knob on to the other interface. Okay, so pretty simple change. Hopefully that makes a difference. Aha, so now we've got a backup hop, next hop that is eligible, and it's eligible over GE001 here. Before we had link protection only enabled here, so it was already learning it from there. So it's not going to have a cost equal path, or well, it's not going to have a loop-free alternate path because it's not an alternate path. It's the main path this way. The alternate path is going to be here. So if I don't have link protection enabled pointing to that alternate route, very clearly I'm not going to have an alternate route. Okay, so let's get rid of the filter on this command and look at the whole thing. Okay, so so one thing, no, okay, I see. So yeah, let's make this easier to read. And now we have, and you can see if I do a Control-Z, Control-Y, oh, we've got a few things that are different. The first thing, primary next hop link fate sharing. So there are now more clear reasons why other routers are not eligible for a loop-free alternate route. Router 6 is not eligible because the primary next hop link fate sharing, that's the reason given. Router 2 is not eligible because of path loops, but router 4 is eligible and the backup next hop is available over GE001 on this router, router 1. That's going to be sent through a LDP signaled LSP and arrive to, yeah, so that's the next hop that's going to be used is router 4, and it looks like it's going to be a MPLS, a LSP. Okay, so same thing for level 2 results. It looks like I've only got a few minutes. I'm going to move on from this topic in the next video. This will be the last one. So let's see that next hop in action. The loop-free alternate route. Let's see that in action. So I'm going to do a ping on 1.1.4. Well, before I do that, I'm going to do a show route to show that it's got a ECMP now. Yep, so now it's got an equal cost path. Of course, I've got a different label than they had there, but there's my loop-free alternate route. So let's pick out the route that I would like. Okay, so we've got .4.8 here. Yeah, so let's ping to that. Okay, and then let's kill the link here on the other side so that it can't use this shorter path here, and it's got to fall back to its loop-free alternate route. God damn it. I don't know. Okay, I had to take that call. That was for internet payment. Oh, right. So I'm gonna take a few extra minutes. I don't have a meeting or anything. I started a few minutes late, so I'm gonna say I have about 5 more minutes, maybe less than that. But I definitely want to see what happens when it fails over to that cost equal path. So let's shut down GE001. Okay, and now we should see something change. Yep, so you can see destination net is unreachable, but hopefully we'll get those pings working again if it can switch over to the cost equal path. Depending on what I'm actually pinging to. Oh, okay, I'm pinging to .1.4.8, so yeah, that's not going to work. So I'm going to do a rollback 1, commit, and then I'll ping to the loopback instead. Yeah, because if the address I'm pinging to is down, clearly I won't be able to ping it. So I will ping to an address that is up. You can see my rollback worked good because I've got my pings back up, but of course it's not going to work to ping an address that will go down. Loopback address is going to continually stay up even though I shut down the physical interface on R5. So let's just roll that back and shut it down again, and we'll see it switch over. Okay, so we might, if it's really fast, it might just be seamless and we don't see anything happen at all. Yeah, so it looks like it might have happened seamlessly. One thing we can do to see if it worked is do a trace route. Okay, so we can see the first hop is 1.1.6.11. Let's see if it changes when I undo this. Okay, it looks like I don't have any changes, so I don't know if my configuration is messed up. That is attempting to get rid of this, or maybe it's using yeah, that's interesting. I'm not sure. Maybe it's using this path initially. Yeah, let's see. Let's do a show route on this, if I may. Looks like I may not. Can I do a space? There we go. Okay, yeah, so, aha, so for some reason, um, what the heck? That's really weird. Oh, you know what? So I've been shutting down the wrong interface. Oh, and right now the interface is up. So yeah, let's try this again. So we're going to do a set interfaces disable. And this is the interface facing router 6, so the smaller path we can see here, it chose the path out ETH2 here, which translates to GE0. But now that I have that shut down, it'll be able to fall back to this alternate route, so we'll see this chevron here move down. Yep, so the chevron moved down to this route here. This initial route is no longer available now, so it just disappears. Yeah, so that's evidence enough. I think I'm going to do a rollback one commit. We'll see the chevron. We'll see a new route come back, and we'll see the chevron point to it. Hopefully, or not. I don't know what's happening. Why is this not happening? Okay, so you know what? Ah, there we go. I think it's because there's a delay in my calculations. Okay, but let's ping this and then take a look at what happens when one of those links fails. It should just automatically come back again. I think we probably will lose some pings, but that's what I'm curious about finding out. So we'll do a show pipe compare. Yep, and we're gonna disable the shortest path, so it has to take that alternate route that it has. Oh, so yep, it looks like we are losing some pings. Yeah, so you can see this sequence here. It keeps track of the order in which the pings were sent, and we can see the 18th ping. After that, it lost, let's see here, it lost ping number 19, 20, 21, and 22. So it lost 4 pings, picked up at 23. Really quick changeover there. And you can see the TTL also moved down, which is interesting because I thought it would actually be a higher TTL on that loopback route. Another thing I can do, and I'm gonna stop with this, is I'm gonna do I'm gonna try this again. We're gonna use a different kind of ping, one that'll be more familiar to Cisco users. We're going to use rapid here, so this is more familiar, I think. And then we'll do yeah, count and do a lot of them. Okay, and now we'll roll back one, commit. So it's kind of interesting that it's losing pings when so I didn't commit yet, but it's kind of interesting that it seems to be a little bit more reliable when it has the ECMP paths. But even then you can see it's kind of it's kind of blinks out a little bit. Here you can see it's switching over. But it's kind of interesting that it doesn't seem to be as reliable using MPLS. Anyways, that's all I've got time for. I got to get back to work. Thanks for watching. See you in the next one. Move on to a new topic.